Hello, and welcome to our 6WIN Turbo IPsec video on mobile infrastructure security. 6WIN Turbo IPsec high-performance software runs on commercial off-the-shelf servers and provides a 50 to 80% savings in CapEx when compared to hardware IPsec VPN appliances. It provides scalable performance on demand and is quite flexible with the ability to run the same software on bare metal or as a virtual machine. 4G and 5G networks converge data and voice onto a single IP-based network, bringing security challenges. A security gateway is needed that meets performance, virtualization, high availability, management, and monitoring goals. Next, we will show a series of 6WIN Turbo IPsec demos targeting each of these four requirements. The first demo is the security performance demo. 6WIN Turbo IPsec performance scales linearly with the number of cores. We achieve 12.5 gigabits per second per core. In addition, 6WIN Turbo IPsec supports up to 100,000 IPsec tunnels at a setup rate of 1,000 tunnels per second. The demo test configuration comprises an Intel x86 commercial off-the-shelf server with 14 cores, 4 10 gigabit Ethernet ports, and a single 100 gigabit Ethernet port. The 100 gigabit Ethernet link carries all encrypted traffic. A traffic generator supplies the traffic across 8 10 gigabit Ethernet ports. The IPsec tunnel termination device also acts as a media converter. This test demonstrates 6WIN Turbo IPsec aggregate IPsec zero loss throughput when the data plane is configured with 8 dedicated cores. In this test, we create multiple IPsec tunnels to maximize throughput. This test generates traffic in both directions across all 8 IXIA ports. The IXIA gauges indicate a combined transmit and receive rate of 78 gigabits per second with a packet size of 1,420 bytes. That's 100% line rate of the 10 gigabit Ethernet links and well within the capacity of the 100 gigabit Ethernet link. We achieved 10 gigabits per second of IPsec processing capacity per core. This next test will determine 6WIN Turbo IPsec's tunnel setup rate. The bare metal test configuration comprises the same COTS hardware and same 6WIN Turbo IPsec software. To test tunnel setup rate, a second server is configured with the Strong Swan load tester. We will create a total of 100,000 tunnels. We start the test. We'll focus on two graphs that monitor security associations created and security association setup rate. Each IPsec tunnel comprises two security associations. The top graph tops off at 200,000 total security associations, which is equal to 100,000 IPsec tunnels. The bottom graph shows a constant security association setup rate of 3,600, equal to 1,800 IPsec tunnels per second. We move on to the virtualization demos. Virtualization readiness means the same 6WIN Turbo IPsec software is deployed on bare metal, on KVM, on Hyper-V, and as we shall see in the demo, VMware ESXi virtual environments. The demo comprises a 6WIN Turbo IPsec virtual machine on host 1 that has multiple tunnels established and is processing crypto traffic. As the VM is migrated to host 2, IPsec operation is continuous since migration is transparent to IPsec. No tunnels are reestablished and traffic flows uninterrupted. We have a 6WIN Turbo IPsec virtual machine encrypting traffic on ESXi host 10.81.1.17. We use VMware vMotion to migrate the virtual machine to a different host. The process takes several seconds. Progress of the migration is monitored. On completion, the 6WIN Turbo IPsec virtual machine is now on host 10.81.1.16. The graph monitors the traffic on the encrypted link with no appreciable traffic interruption. We conclude with the virtualization readiness demo and move to the high availability demos. 6WIN Turbo IPsec is deployed on multiple COTS servers in active standby configurations to provide local and geo redundancy. For local redundancy, VRRP and IPsec HA are used to ensure fast failover. In normal operation, the tunnel terminates at the active security gateway. When the active gateway fails, the tunnel immediately fails over to the standby security gateway. This failover is transparent to IPsec. Geo redundancy provides failover in the case of a complete site failure and depends on BGP operation. The IPsec tunnel terminates at site A. When site A suffers a complete failure, the tunnel is reestablished at the active security gateway in site B. We turn to the local redundancy demo. The bottom gauges show the traffic generator transmit and receive rate. The top gauges show traffic flowing through the active security gateway. Now we shut down the active security gateway. The gauges confirm the security gateway is down. We check the standby security gateway and find it is now the active security gateway, confirming proper local redundancy operation. The geo redundancy demo simulates a complete site failure by shutting down Site A active and standby security gateways. This time, the traffic generator receive rate goes to 0. We check the Site B active security gateway and find it is handling the traffic. After a few seconds, the traffic generator begins to receive traffic again. We've come to the last of our demos, management and monitoring. 6WIN Turbo IPsec provides management choices to help with OSS and Mano integration. For example, in the preceding demos, we took advantage of third-party tools to monitor network throughput, IPsec statistics, CPU utilization, and also data plane statistics. In closing, we've shown that 6WIN Turbo IPsec is a cost-effective alternative to hardware IPsec VPN appliances with all the features to secure the mobile infrastructure. Contact us today to learn more about 6WIN Turbo IPsec for your specific requirements.